Okay, in the next few videos, we're going to work through the notes from this foldable notes booklet, Evaluating with Trig Identities. You'll notice that all of these examples refer to the Trig Identities Hexagon, which we learned about in the math lab in our last set of videos. So if you skipped that, this is not going to make a whole lot of sense. You probably want to go back and watch those. And if you don't have printer at home, you can go ahead and copy these examples from the notes booklet down onto your own paper. Okay, so in example 1, we are given that the secant of x is equal to the square root of 2. So I'm going to go ahead and put that on the hexagon. Secant of x is square root of 2. And we also know that the sine of x is negative square root of 2 over 2. So we'll add that one to our hexagon. Negative root 2 over 2. So we still need to find the tangent, the cosine, the cotangent, and the cosecant. Okay, we know from the hexagon relationship for the identities that the left and right vertices will multiply to give the center one. So sine times secant is equal to tangent. That's a product identity. So sine of x times secant of x, that is equivalent to tangent of x. So if I substitute in what I know, that the sine is negative square root of 2 over 2, and the secant is square root of 2, I'll put that over 1. Then I can simplify. So square root of 2 times square root of 2 is just 2. And that's over 2. And then negative 2 divided by 2 is negative 1. So the tangent of x is negative 1. Okay, if we use some reciprocal identities, then the reciprocal of tangent is cotangent, and the reciprocal of negative 1 is still negative 1. Okay, then the reciprocal of secant is cosine, and to find that reciprocal, then we know cosine of x is 1 divided by square root of 2, because that's the reciprocal, and that would be a radical in the denominator, so we have to rationalize that denominator. And that leaves us with positive square root of 2 over 2. So the cosine is positive root 2 over 2. Okay, then to get our cosecant, we could do this product property here. So the cosecant of x is equal to the cotangent of x times the secant of x. Cotangent is negative 1. Secant is root 2, which is negative square root of 2. And then we have them all. Now, you could have, instead of using a product identity, you could have done the reciprocal, right, and said the reciprocal of sine is cosecant and rationalize the denominator. You could have done a quotient identity. There's lots of ways to get these when you're using the trig hexagon, but this is just one example that you can try.